given this and we are asked to find the area of a square. We are asked to find the area of the square. Okay, looking at this. Okay, let us call the length. This is a square. This is square PQRS. So let's call the length, the side length x. So here is x. Again, looking at this 8 system, this is a right angle triangle because they form a Pythagorean triple. So it's a right angle triangle. So here, so if I call here theta, here should be 90 minus theta. Yes, because this is 90, so the remaining should be 90 minus theta. And also here is 90 minus theta. Since this is 90, this is 90, this is also 90. So we have to solve this using similar triangle because our main aim is to find if we know x. That's the answer. So let's call here y. Here should be y, x minus y, because the lengths are the same. The sides are congruent. So let's apply similar triangle to find the value of x. From here, I'm comparing this triangle, this small one, with this. That this triangle. I'm saying that triangle PQU is similar to triangle URT by right triangle similarity theorem. So which implies that x minus y over x. So this side corresponds to, remember this is 90 minus theta 90, this is also 90 minus theta, so it corresponds to x. X minus y corresponds to x must be equal to, check the hypotenuse is 8 here, while the hypotenuse here is 6, so 6 minus 6 over 8. Do you get the hypotenuse? That's it, corresponds to that. So this is y over x. X over x is 1. So 1, so this minus y over x crosses here to be y over x. So this should be y 1 minus 6 over 8, which is 8 minus 6 is 2. 8 minus 6 is 2. So 2 over 8, which is 1 over 4. So y over x is 1 over 4. So x is equal to 4. X is equal to 4y. So, but remember, we can still solve something again. We need to find, this is right angle triangle. So using Pythagorean theorem. So from Pythagorean theorem, from triangle PQU, you notice that x squared plus y squared must be equal to 8 squared. Pythagorean theorem. So x squared plus y squared must be equal to x squared. So, but we are okay. Remember, we are looking for x. So x squared, y is now x over y over 4. So we replace this as x over 4 all square must be equal to 64. So I replaced y. Remember, x is equal to 4y. So y is now x over 4. So we square x squared plus x squared over 16 equals 64. You are still going. So factor x squared, we have 1 plus 1 over 16 equals to 64. So this x squared, 1 over 16 is 17 over 16. So 16 over 17 times 64. Do you get 1 plus 1 over 16 is 17 over 16. So cross multiply. So which is now 16 over 64 over 17. So we are looking for, okay, we are looking for the area of the triangle, of the square. So that's the area is x squared. Yes, x squared is the area. So area is now 16 times that. So 4, this should be 4, this is, okay, this should be the 16 times, this is 4, carry 2 third, 40 plus this 2, carry 4, this is 1, okay. That's it. Looking at the option, it seems, okay, it should be B, 60, because that's it, this one, this 64/7. Or this 10, 1020, 60 times 17. So the answer is B. Our answer is B. Okay, the next question. The equation looks, if you solve it the normal way, it takes time. So there is a formula for this, a very nice formula. That once you are given 3 parallel lines, A, B, E, F, because they are 99, so they are parallel. That the middle, the length of the middle one, EF, is just the product of this, of the other two lengths over their sum. Yes, it's a very nice formula. So this is 15 times 3 over 18, which is 65 over 2. That's it. Without wasting time, the answer is 5 over 2. You'll be wondering, how come I derive the formula that I used to solve this question? Assuming I have a parallel line this way, and I have another parallel line this way. That's the line parallel to this. So assuming this line is parallel to this, and I have, this is joined to this, why this is joined to that. So assuming a line, yes, so I'm saying that this line is parallel to this. If this line is also assuming another line that is parallel to the two is this. Assuming you have another line, so let me name this, if it's A, B, C, D, E and F. So you notice that assuming the length here is A, why this is B, the middle is C. We want to get a formula connecting A, B, and C. So since the parallel line, assuming here is theta, remember from alternate angle theorem, here is also theta, yes. And assuming here is beta, here is also beta. And since this is parallel to this should be theta also, because this line is parallel, so this corresponds to this. And also since this is parallel to this, here should be beta, yes, because this line there, corresponds to this. So assuming the total angle here, assuming the total angle is, okay, assuming since they are parallel, here is also gamma, so here should be gamma minus beta, yes, because since they are parallel now, so this corresponds to this. So again, assuming here should be 180 minus gamma based on linear pair postulate. And again, since here is 180 minus gamma, here should be 180 minus gamma, because here corresponds to this. Are you following? So I'm saying that here should be, so the remaining angle here should be 180 minus theta minus gamma, because this is a triangle, so angle sum must be 180. So you notice that we form similar triangles here. Yes, I'm saying that triangle A B D is similar to triangle A B D is similar to triangle F C D. Yes, so it's similar to this. Okay, let's call here, assuming here is X and this is Y. So let's derive something very important, since they are similar, which implies that the ratio of the corresponding sides are proportional. So x plus y over, if you notice, this is theta for the bigger triangle, is opposite x plus y. This is also theta, so is opposite what? Y. Must be equal to the side here, the angle here, 180 minus theta minus alpha. Gamma is opposite to A, should be A over that same angle is opposite to C. So therefore x over y, this is x over y 1, y over y is 1, so A over C minus 1 is now A minus C over C. So that's equation 1. So for equation 2, you notice that triangle EGB is similar to triangle FBC. Yes, by angle similarity postulate. So which implies that the same x plus y over, but here remember this beta is opposite x plus y, so my beta here is opposite x, so over x must be equal to, what's the sides here? B over that same C. Therefore y over x is B minus C over C. Yes, because this is 1, x over x is 1, so 1 crosses. So if you reciprocate, x over y is now C over B minus C. Call it equation 2. So we have two equations that are the same. X over y equals, so I'm saying that A minus C over C is now equal to C over B minus C. So if you cross multiply, we now have C times C squared equals A minus C times B minus C. And if you open up, this AB minus BC minus AC plus C squared, and C squared is gone, C squared is gone, so BC minus AC comes here, is now A plus B times C, remaining AB. Do you get? Minus cross is plus, so they have C as a common factor, so you factorize, so C is now AB over A plus B. So it justifies the formula that I use in solving this question. So whenever you have A, once you know A and B, the value of C is just the product over the sum. So that's it.